Hi, I'm Kate Guttridge, and I'm a partner solutions engineer here at StreamSets. I work with our ISV partners, including Snowflake. Today, I'm going to introduce you to Transformer for Snowflake, which is built on Snowpark. I'm going to give you a brief overview of our partnership with Snowflake, and then tell you what we do here at StreamSets with the DataOps platform and the main event, Transformer for Snowflake. At the end, we'll try to answer some of your questions. StreamSets offers a data integration platform designed for modern analytics. What that means is that you can build, operate, monitor, and manage smart data pipelines from a single, scalable, cloud-native platform. StreamSets supports multi-platform, multi-cloud, and multi-pattern data pipelines. We became Snowflake partners in 2019 and have focused on product innovation with them from day one. We're a validated technology partner, have certified as Snowflake ready, and our latest Transformer for Snowflake capabilities are part of the Snowpark Accelerated program. So what exactly makes the StreamSets DataOps platform? The DataOps platform was developed to support organizations embracing a DataOps mindset, one that actually operationalizes data integration to ensure resiliency and agility in the face of data drift, which is the unplanned, unexpected, and unending changes to your data. The DataOps mindset is the only way to keep up with the demands of modern analytics. Only with StreamSets can you deliver data at the speed of need while also being confident in your data integration operations despite a constantly changing environment. Our platform's single design experience for all patterns lets you deliver projects 10 times faster and keep up with the business demands. Our smart data pipelines are built for change, avoiding 80% of break fix and rework. Our control hub lets you monitor and manage all your pipelines on any infrastructure and on any cloud. So how are StreamSets and Snowflake customers using this approach to solve their critical business problems? One of our joint customers is TechBridge, a national nonprofit headquartered in Atlanta with a mission of breaking the cycle of generational poverty through the innovative use of technology to transform nonprofit and community impact. One organization TechBridge supports is the United Way of Greater Nashville's Family Collective, which focuses on preventing and ending homelessness for 5 counties and 24 nonprofits in the Greater Nashville area. They were challenged by changes in data across multiple sources, and that was blocking the ability to share data between the groups that needed it the most. By implementing a StreamSets and Snowflake solution, each partner could utilize their own client management system and enable bidirectional data sharing between partners and funders. Each partner could understand which programs families were receiving and the outcomes achieved. Let's take a closer look at how customers like TechBridge are able to achieve these results. We designed the StreamSets DataOps platform to take a modern approach to data integration that addresses multiple challenges, keeping pace with modern analytics. Our platform provides different engines optimized for different use cases and pipeline patterns. The data collector engine is designed to ingest data into data lakes, object stores, message brokers, and more, supporting multiple modes, including batch, CDC, and streaming ingest. Our transformer engine is designed for heavyweight, set-based operations and transformations, such as ELT or ETL, needed to conform data for analytics or AI ML running on Spark. With the addition of Transformer for Snowflake, StreamSets is offering our first fully hosted solution that enables users to perform ELT in Snowflake through building pipelines in the StreamSets UI. To do this in our previous Transformer for Spark, data needed to be extracted from Snowflake so the transformation workload could be executed on a Spark cluster, and then the results would be loaded back into Snowflake. With Transformer for Snowflake, users get all the benefits of the DataOps platform with built-in monitoring and orchestration of complex data pipelines, combined with the compute power and security provided by Snowflake. Because Transformer for Snowflake is built using Snowpark, we are able to build the pipelines in StreamSets to generate the SQL that is then executed in place in your Snowflake data cloud. This minimizes the risk of moving your data across platforms and saves on the cost of data egress and ingress charges, allowing you to focus your Snowflake credits on the data transformation itself. The key component that brings all of this together is the control hub, and that's the central nervous system of the DataOps platform. It's the single interface for building, operating, and monitoring all data pipelines, no matter which engine is executing them, no matter which platform they are connected to, and no matter what they are, on-premise, in a VPC, or on a public cloud, or hosted by StreamSets. You can have data collector pipelines doing Oracle CDC to Snowflake, others streaming Kafka on-premise into external stages in AWS S3, Transformer for Snowflake pipelines evaluating data quality, populating your data warehouses, or preparing your data for ML modeling. Using Control Hub as your single pane of glass eliminates blind spots and control gaps, so your data engineers and platform operators no longer need to swivel chair between different control systems. In other words, the StreamSets DataOps platform is your mission control for your entire data integration environment. So let's explore why you'd want to use StreamSets with Snowflake as opposed to an alternative. The StreamSets DataOps platform meets the integration needs for nearly every Snowflake workload you have, from ingest to transformation to complex analytic needs. Now let's specifically talk about Transformer for Snowflake to see how our integration with the Snowpark API allows you to leverage the full power of StreamSets without moving your data out of Snowflake. Based on the Snowpark API, Transformer for Snowflake enables data engineers to go beyond basic SQL to express powerful data pipeline logic in StreamSets drag and drop UI, while still taking advantage of the expressiveness and flexibility of Snowpark's multi-language support. This slide encapsulates the full range of Transformer for Snowflake's capabilities for pipeline development inside the DataOps platform. It includes all the SQL basics like joins, sorts, and unions, dynamically defined pipeline configurations that also allow you to embed libraries and create UDFs, and stages that are pre-programmed with complex logic to support common use cases. Before we take a look at all that, let's see how quickly you can get started in Transformer for Snowflake. As I mentioned previously, Transformer for Snowflake is fully hosted. So once you have a DataOps platform account, you're only a few clicks away from your first pipeline without having to deploy any engines or infrastructure. Once you log into the platform, you can see here that we have no deployment set up. All you need to do is go into your user settings and provide your Snowflake credentials, and if you choose some default pipeline configurations that will come in handy later. After that, you're ready to build your first pipeline. Go to add a pipeline, select Transformer for Snowflake, enter a few details, and you're on the canvas and ready to build. All you need to do now is add your Snowflake table and specify the table you want to read. And we can use the StreamSets preview feature to confirm that we can access the data in the Snowflake table. And trust me, as you do larger and more complex pipelines, preview will save you so much time opposed to trying to select and execute subqueries and portions of your SQL to test and troubleshoot. Now that we've seen how easy it is to create a pipeline, we can look at how Transformer for Snowflake helps make pipeline development easier and more flexible through its dynamic query generation using Snowpark. Whenever a new data set arrives, especially from flat files, we all know that there is work involved to get that data into the right shape to work with downstream. To do this in SQL is a fairly tedious process. Casting values as different types, renaming fields, trimming and applying other functions, all this needs to be defined explicitly for every column in your query, which is just opening the door for typos, copy-paste mistakes, and other issues. You don't actually need to do that if you build your pipelines with Transformer for Snowflake, which is able to dynamically generate that SQL at pipeline runtime. Transformer for Snowflake has a special apply functions processor just for this, which can use standard SQL functions as well as UDFs defined in Snowflake or directly in your pipeline. This processor allows you to use regular expressions to define the columns you want to transform. And when you run the pipeline, StreamSets evaluates that expression and generates the correct SQL with the help. Here's a data set of trips data from the City Bike rideshare system in New York City. You might notice a lot of the columns have extra quotes that need to be removed. And if we were writing SQL, we need to apply a trim function separately for every column in the table. But in Transformer for Snowflake, we can accomplish the same thing using the apply functions processor, a very simple regular expression, and selecting the desired function. This means that if columns are added to the source down the line, no one would need to go back into the pipeline to fix it. I also noticed the data set has different formats used for the trip start and end times. So I wrote a SQL UDF in Snowflake to try multiple date time formats for each value and then cast it appropriately. I'm even able to call that function from Transformer for Snowflake and then apply it to all the columns with the names ending in time. We can now use the preview to check that the output of this processor is showing the extra quotes have been removed and our timestamp fields have been added. So if we take a look at the SQL that would be needed to accomplish the same task, it doesn't look too terrible since there's only 15 columns in the table, but imagine that you needed to do this for 100 columns. How many copy paste errors will you find before you get the query to run successfully? So I'm not going to take you through every step, but we can use regular expressions to do things like converting field types as seen here, or to rename or remove columns in the pipeline. And finally, I'm adding a table destination here, which is where you configure how you want the pipeline to write the results to Snowflake. We can then run the pipeline and we can take a look at what's happening in Snowflake. We find the creator replace table statement, and this makes sense since we specified that the table should be overwritten each time. We see that the table was successfully created, and if we query that table, we can see that it indeed was populated with over 2 million records, and we can even glance to make sure that the records look like what we're expecting. So there, we've now created a pipeline that will do some data cleansing, and will keep on running if additional columns are added. But what happens if the data source changes entirely? Well, that exact thing happened last year when City Bike changed up their file format completely. They added, removed, and renamed some of the columns. So now that means we need to add a new data source to our pipeline, and we know that we'll need to use a union processor to bring the two data sets together. In our union, let's use the StreamSets setting to pass all fields. So unlike writing SQL, the processor will match up the columns based on their names, and for columns that don't exist in both data sets, it will include the column in the output, like you can see here. We can add a field renamer to handle any columns we want to overlap. And when you run the pipeline, we can then look again in Snowflake to see the target table had columns added that didn't exist previously. So we know that the new columns from the data set made it all the way to the end of the pipeline. We can also see the insert query, and that shows, if we dig a little further, that it inserted around 28 million records. So if we look at what the pipeline looks like, if you write it in SQL, you can see a roughly equivalent query here, and notice how the columns have to be ordered and declared in order to get the same results we get with the StreamSets pipeline. One more feature that I'm going to tease you with really quickly is the pivot processor. If you've ever performed a pivot in SQL, you know that you have to go through the tedious process of declaring each new column name. So for example, if you want to pivot by month, you need to define in your query each of the values in the month field that will become columns. Needless to say, it's not super flexible, but in Transformer for Snowflake, you have the option to skip this step entirely with one click. This is just another way that using Transformer for Snowflake can provide that extra level of flexibility that SQL queries alone can't provide. And this will save you time defining the pipelines and preventing breakage when the data changes. I think it's worth noting that through all the changes we just made to that pipeline, it never broke, and I never had to make any changes to the destination, which I think is pretty cool. Hopefully now you have a sense of how pipelines built with Transformer for Snowflake provide a level of flexibility that accommodates data drift and just can't be done in plain SQL. And that's all thanks to Snowpark. Even with our drift resistant pipelines, we also need to implement the logic to perform calculations, analyze data, implement business logic, and build and maintain our data warehouses. This is another area where Transformer for Snowflake pipelines can make that easier. Transformer for Snowflake supports UDFs, including those defined in pipelines or elsewhere. And it has processors that come pre-programmed with a standard but complex logic. And we even have fragments, which are a stage or a set of connected stages that you can use and reuse across your pipelines to reduce duplicating the same code. Thinking again about the city bikes trip data we just processed, as time goes on and we continue to collect this trips data, we decide to collect more data about the system, starting with the stations. And we want to track those changes in a slowly changing dimension. Trying to do this with standard SQL would be challenging, to say the least. Or you can leverage Transformer for Snowflake's slowly changing dimension processor that's gone a step further by encapsulating this logic into one component. This allows you to plug in a few configurations and pair that with a table destination that will seamlessly merge your data. I have two tables here. One is my existing dimension, and the other is receiving the daily station updates. With these tables feeding the processor, all that needs to be done is to choose the entity's key fields, the dimension type, and one or more of the change tracking methods within the dimension. Based on this, the processor will produce an output that has new and updated records, which is then sent to the Snowflake destination for the merge. The table destination has a setting just to handle the output of this processor, and that is all that needs to be done. Running the pipeline on a little sample of data, we can see that one of the stations has had a change in capacity, and we can actually go and look at those results directly in Snowflake. If we now look at the query history, we can see a summary of the inserts and the updates that were generated by running the pipeline. We can also look at the monster SQL query that's generated to implement this logic that only required one processor and a couple column names. Now, not only are there updates to values in a dimension, but as businesses evolve, so do the systems and the data they produce. So what happens when new station attributes are added to your source data, like if a station can dock e-bikes? This new data can just appear in the feed, and you might want those new attributes to be reflected in the dimension. In the SQL world, you need to know about this change in order to create the new column. However, since StreamSets was designed with data drift in mind, the SCD processor even has a special setting to decide how to handle the addition of new columns. So your pipeline never breaks or has to be edited. It just works. That's one use case, but there's so much you can do with Transformer for Snowflake. I just don't have the time to show it all today. I've shown a few of the ways Transformer for Snowflake equips its users with the tools to efficiently build pipelines that are resilient to data drift. They're defined dynamically at pipeline runtime, and they use complex logic that's provided out of the box or can be added through user-defined functions. We did have a limited amount of time today, but there's more that Transformer for Snowflake can do, such as the deduplication and JSON processors. And all of this is in addition to the standard SQL functionality of performing joins, unions, etc. Thanks to the Snowpark API, StreamSets was able to add this powerful transformation solution to our platform, using Control Hub to provide a single interface for the building, operating, and monitoring of all data pipelines wherever they're running. But don't take my word for it. Go try it out yourself. There's a free, fully featured StreamSets DataOps trial. No code needed. Just go to the website and sign up. And you'll be able to get your hands on the full power of the DataOps platform, which includes Transformer for Snowflake. So just go to streamsets.com, hit the Get Started button, and you'll be well on your way to starting your trial of Transformer for Snowflake and the rest of the DataOps platform. Thank you.